All right, class. In this lesson, we are going to learn the end behaviors of polynomial functions and also their transformations. All right, so let's go and get started. All right, so in this left side of information, I know there's a lot of information here, but if you focus in on just what this is telling us, odd degrees of polynomial. So when we talk about odd degrees, we're talking about x to the third power, x to the fifth power, x to the first power. Okay, so that's odd degrees. And when we have a positive leading coefficient, okay, so the number in front of the x, here it's implied to be 1, here it's 0.5, here it's 2, okay? So when both of those conditions are met, then our functions will essentially follow a behavior similar to this linear function, okay? This linear function is a positive slope, and the ends go infinity in this direction and also into infinity or negative infinity in this direction, okay? So you'll notice that g of x here, which is 0.5x cubed minus x squared plus 3, has a degree of 3. This is an odd degree function, but even though it curves in the middle, eventually it goes up and to the right into infinity and down and to the left into negative infinity, similar to this line. And then if you look at this other function in green, which is to the power 5, okay, we may have a curve here, but essentially it goes up and slightly to the right into positive infinity. And then down here, it goes down to, it goes down and slightly to the left into negative infinity, okay? So in all three cases, the behavior is very similar to this. They extend out into infinity and down here into negative infinity, and it's in this direction, okay? Now let's take a look at the second set. Here we have functions that are in even degrees, okay? X to the second power, x to the fourth power, x to the sixth power, and the leading coefficient is positive. So here we have an implied 1, 0.9, and 2. Okay, notice that in all three cases, no matter what happens in between, the ends basically go all the way up to the right, and here it goes up and to the left. Okay, let's take a look at this blue function. It goes up and to the left. It's going to curve down, but then eventually it goes up and to the right. And the same thing with the green function here. It goes up and to the left. It's going to curve back down and then go all the way up to the right. Okay. So in all three examples, they all point up to the left and to the right. So in essence, the end behavior is similar to the quadratic parent function of f of x is equal to x squared. Okay. And that's what this function is. It has a similar behavior as that. Okay, let's take a look at two more scenarios. That was odd degrees and even degrees with positive leading coefficients. Okay, now we're looking at odd degrees and even degrees with negative leading coefficients. Okay, so with odd degrees with negative leading coefficients, okay, negative, 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 we see that it's going to be in this negative slope direction. Same thing with this blue and this green, okay? So the ends basically go up and to the left, and on the right side, the ends go down and to the right. So the end behavior is similar to f of x is equal to negative x, which is this function here. Okay, and then the last set, we have even degrees, except now we've got negative leading coefficients. Here's a negative 1, negative 0.9, negative 2, okay? Now, in this case, we have the direction, the end behavior is pointing down into the negative, okay? So basically, the end behavior is going to be similar to f of x is equal to negative x squared, which is this red parabola, okay? You see the green going down and to the left, going down and to the right on this side. The blue is going down and to the left, and on this side, it's going down and to the right. Okay. Now, let's move on to the topic of odd and even function. Okay, so a polynomial function is an even function if it is symmetric about the y-axis, and an odd function if it is symmetric about the origin. Okay, so let's take a look at the even function for a minute. An even function is going to be symmetric about the y-axis. So take a look at this parabola. Okay, the axis of symmetry is right here, is our y-axis. Okay, and notice that it is symmetric on both sides, meaning if I count the distance from here to this part of the parabola, the same distance is also even or equal in the opposite direction. Okay, so you'll see that the symmetry is along the y-axis. Okay, this is a reflection of this, and then this is a reflection of that. That's for an even function. Now for an odd function, its symmetry is about the origin. So let's take a look at this odd function. This is actually f of x is equal to x cubed. Okay, and you notice that the distance from the origin to this point is the same as from the origin to that point. Okay, and if you pick anything along this function, okay, that distance to any point over there is going to be the same as any point down here. So the reflection or the symmetry is about the origin. Okay, and that is the case for odd functions. Okay, so now how do we identify an even and odd function from their equation? Okay, well, let's take a look at this function. F of x is equal to 4x to the 4th plus 5. So to determine that, we're going to take f of negative x and see what that gives us. Okay, so that's going to be equal to 4 negative x to the 4 plus 5. Okay, and what we discover is that f of negative x is equal to 4x to the 4th plus 5, which is exactly the same as what we started with. Okay, so what that means is an even function tells us that f of negative x is equal to f of x. Okay? All right, now let's take a look at this other function. G of x is equal to 2x cubed plus 3x. What happens when we substitute g of negative x into this function? Well, let's go ahead and figure this out. This is going to be equal to 2 times negative x cubed plus 3 times negative x. Okay, that works out to negative 2x cubed minus 3x, which is the same thing as negative of the quantity 2x cubed plus 3. Okay, so essentially what we get is almost the same as what we started out with. The only difference is we have this negated. Okay, so then an odd function is when f of negative x is equal to the negative of the function that we started out with. Okay, all right, so let's go ahead and move on to the next and put it all together. And we're going to talk about the transformation. Okay, transformation. So here we have a graph, we have a function, and the question is how can we determine the equation of the graph if this represents a transformation of the parent cubic function? Okay, so what is the parent cubic function? It's f of x is equal to x cubed. Okay, and that parent function actually is right over here. And go ahead and draw this. It's a dotted line. Okay, so this is our parent function. So essentially what we are seeing is that this is a shift to the left 4 intervals. Okay, it's a shift to the left 1, 2, 3, 4 intervals. So then my parent function, the equation of this function, of the transformed function, is going to be f of x is equal to the quantity x plus 4 cubed. Okay, y plus 4, because it's going to the left 4 intervals. Now it's counterintuitive because we see a plus 4 and we automatically think that it should go to the right. But in this case, because of the way the function is structured, the interval of a positive 4 means that it's going to shift to the left. If this were minus 4, then it would shift to the right 4 intervals. Okay, now let's take a look at one more function. Okay, so the graph below here is a transformation, so it means it's been moved from the parent quartic function. And the question is, what is the equation of this graph? Well, the parent quartic function is as follows. It's f of x is equal to x to the 4th. Okay, quartic means to the power of 4. So the parent function would normally be over here. I'm going to go ahead and graph this. Let's see here. It's going to be over here. And it's going to be a crude drawing. Okay, it looks like a parabola, but it's kind of stretched out from side to side. And so if this is the parent function, the question is, what is the transformation of this new function? Okay, what is the equation of this function? Well, let's take a look. We know that this function shifts to the right 2 places, and it goes up 1, 2, 3, 4, 5. Okay, it goes up 5. So then the equation of the graph is going to be f of x is equal to, and we said that it shifts to the right 2 places, so that's going to be an x minus 2. Like we said earlier, it's counterintuitive, right? To the right it's going to be negative, it's going to be minus 2. If it goes to the left, it'll be plus 2. So it's going to be, in this case, it's going to be x minus 2 squared, and we said that it shifts up 1, 2, 3, 4, 5, right? This thing shifted up 1, 2, 3, 4, 5, right over here. So then that's going to be a plus 5. So this is the equation of the transformed function. Okay, hopefully that made sense. If any of this was not clear, please go back to the beginning of the recording and listen to this again. Thank you.